Many material effects can be described by calorimetric measurements, but not all, and quite often without the mechanical properties that are of primary interest. This is why it's a great joy for me to present our latest developments in the field of dynamic mechanical analysis. And actually there are two instruments I can present today. Our brand new desktop DMA 303 Eplexor, and a redesign of our standalone system for forces up to 4,000 Newton, the DMA 523 Eplexor, which combines the features of a laboratory DMA with the power you need for destructive material testing. But let's start with our desktop DMA. As we started the project, we could start from the scratch with a new mechanical design, new electronics, new firmware, and a completely new software. We did this in order to broaden the capabilities of the instrument. But we did not only improve the performance, but started the development with the usability of the instrument. We changed the position of the measuring cell. Now it is lifted for sample preparation, and the user decides whether he wants to sit or stand in front of the instrument. The instrument will adapt to your needs. But that is not all. Since the alignment of the sample is crucial for the quality of the results, we offer an illuminated sample order for perfect view of the sample. In addition, sample orders can now be changed without tools and automatically recognized by the instrument using RFID. So mixing up sample orders is a thing of the past. But now let's take a closer look at the technical principle of the instrument. Like all Eplexors, the 303 has two drives: a stepper motor for static deformations up to 30 mm and a dynamic shaker system allowing for forces up to 50 Newton. And please note, this is unmatched for desktop DMAs. The deformation of the sample is measured with a state-of-the-art optical position sensor with a resolution of 1 nanometer. When we talk about DMA, most often the instrument shall be characterized at different temperatures. The instrument's furnace and its homogeneous temperature distribution are crucial for the measurement results. So we put a lot of thoughts into improving it. We developed a silicon carbide lined furnace which allows temperatures from -170 to 800 degrees. This temperature range can be used to characterize not only polymers, but also many glasses or even metals. A closer look at the furnace reveals that all surfaces are cooled or heated. In addition, a fan provides forced convection for even better temperature distribution inside the furnace. To sum it up, these features make the 303 a unique DMA. With forces up to 50 Newton, you can measure many samples even in tensile mode. A wide temperature range from -170 to 800 degrees allows materials to be characterized at very low and very high temperatures, opening up new applications. The combination of a static and a dynamic drive provides great flexibility. Whether you're interested in a complex modulus, creep and relaxation, or even universal testing of smaller samples, the DMA 303 Eplexor can do it. But there are some applications where much more force is needed. This is the reason why we offer the new DMA 523 Eplexor with static forces up to 6,000 and dynamic forces up to 4,000 Newton. Should you have larger samples, you can apply dynamic deformations of up to 15 millimeters. This instrument is also equipped with an interchangeable force sensor, so you can easily adjust its sensitivity. This flexibility makes it a versatile instrument that covers a wide range of mechanical and material testing. Using a sensitive force sensor, you may use it as a laboratory DMA. Equipped with a larger force sensor, it has enough power for destructive material testing, like fatigue or universal testing. Or if you're interested in heat buildup under heavy dynamical loads, like it is especially important for rubbers, no problem. These instruments complete the family of niche DMAs. For general viscoelastic characterization, the desktop DMA 303 is the first choice. For larger samples or nonlinear material properties like pain effect, more force is often required, making our 500 Newton system the ideal instrument. And for destructive material testing like fatigue or heat buildup, our new standalone DMA 523 Eplexor gives you all the options. For every application, the right DMA. Thank you.